All right, so in this part of 3.1, we talk about degrees of terms in the polynomial. So each term has its own degree. Now, degree essentially just means how many variables have to be multiplied in order to get that term. So for instance, 2/3 x to the third power. Since x to the third power means x is being multiplied times itself 3 times, we say that's a degree 3. Negative 4x squared is just x times x. It utilizes x squared, which means x times x, so that's a degree 2. 3x, you'd have to multiply one variable, so it's a degree 1. And then 5, if you look by itself, there's no variables involved in 5, so it has degree 0. Now, these are the types of terms that we're going to be looking at for the most part going forward, but we do need to discuss really quickly, what if our terms have multiple variables in them? If our terms have multiple variables in them, like x times y squared, then that means x is multiplied, but then also that y is multiplied twice. So because we have x 1 time and y 2 times, that is a total of 3 variables that are being multiplied. Again, we double count the y's, just like we did up here when we double and triple counted those x's. So negative 2a to the third b squared, that would be a degree 5 because a happens 3 times, b happens 2 times, and if you multiply all those together, you get a degree 5. Now notice that these coefficients never affect the degree. So regardless of whether the coefficient was 5 or 15, the degree is still 0. The coefficient here is 3. If the coefficient was 300, it would still be degree 1. If this coefficient was something other than negative 4, it's still degree 2. Same thing down here. This coefficient is negative 2. The negative 2 really doesn't come into play in terms of the degree. So that's how you find the degree of each term. So why don't you go ahead and push pause on the video and then try to do the 3.1 cooperative group problems on your own. I'm going to push pause on my video, but in about 5 seconds, I'll come back and show how to do that. Right, so we're looking at the degree and the coefficient of each term here in section or lesson 3.1. So of this first 13a squared, the degree is 2 because a squared means a would have to multiply it by itself, so you get 2 variables multiplying together. The coefficient is obviously 13. All right, so the degree is 2, coefficient is 13. The degree here is 0. There are no variables in negative 243, and you could say that the coefficient of the term is negative 243. Some people just call this a constant, and that's what we'll call it later, but for right now, you can think of the coefficient as negative 243. 3/7 x squared y. 3/7 x squared y, the degree here is 3x squared and then y, so 2 x's, 1 y, add to 3 variables that we're dealing with. And the coefficient is obviously 3/7. On problem number 4, we have d to the 6th. Now, the degree here is pretty obvious, it's 6. However, the coefficient is not written down, right? So anytime we don't have a coefficient written down, we always say it's 1. It's an implied 1. We've seen that before in this class, but I just want to state that again. So d6, the coefficient is actually 1. And in a similar way, when you deal with 3 times p, whoops, the degree here is a 1 because we have a 1 variable. Sometimes people will write out the exponent just so 3 times p to the first so that they can see the degree is 1 of that term. And the coefficient here is the number 3, obviously. So there you go. That tells you how to find the degree and the coefficient of each term.